For this video, we are going to be talking about parallel and perpendicular lines. Parallel are two lines that are never touching, and perpendicular lines are two lines that are intersecting at a right angle. So two lines that are parallel, again, are two lines that will never touch. And I always remember that by the L's in parallel, you can see that they are never touching there. So when we see those lines on a function, they're never going to touch. They're going forever and ever and never intersecting with each other. They are going to have the same slope. The same slope. Now, two lines that are perpendicular, they're intersecting at that right angle. In a right angle here, they will have a slope that is the opposite reciprocal. So if it's a positive slope, it's going to become negative. And if, like we talked about multiplying by the reciprocal, you're flipping the numerators and denominators. So if our slope was positive, it would have to change to a negative slope. And if it was negative, it would change to positive. Same thing when we're multiplying by a reciprocal, we have our numerator and denominator in our fraction. It's going to flip over to be our denominator over our numerator. So an example of this, if we have a slope of -4, that's really 4 over 1. So when we change it to have that opposite reciprocal to get our perpendicular slope, we're changing it to 1 over 4 because we're flipping our numerator and denominator, but we're also changing that negative to a positive slope. If we had 1 over 5 and we wanted to change it to a perpendicular slope, the 5 is going to come into the numerator. It's going to be over 1, and it was a positive slope, so now it's becoming negative, and we know that could be written as -5 slope. The last example I really want to talk about is if you have a slope of 0, that's really over 1. When we do that, we're going to flip it over, and that becomes 1 over 0. As we've talked about many times, it's going to be negative. This is not allowed. That would be an undefined slope. So write the equation of a line in slope-intercept form that passes through the given point. And in our first part, so this column, we want to find a parallel to the information given. And part B, this side, we want to find a perpendicular to the information given. So for example 1, it passes through the point -3, -5, and has a slope of 3 and a y-intercept of 2. So we have this line that has a slope of 3 and a y-intercept of 2. So we're saying our equation is y equals our slope of 3 and a positive y-intercept. So if we put that into our calculator or graphed it, our line is looking like this. We want to figure out a parallel line that's going through -3, 5. So it's going to be somewhere over here because it's -3, +5. So somewhere in this region that is parallel to this red line. So the first thing we're going to do is think about if it's parallel, the slope is going to be the same because if the slope is different at all, it's going to intersect. So our slope originally of this line was 3, and it said it's going to pass through this point of -3, -5. So we're going to plug that into our point slope formula. So we're doing y minus -5 equals our slope times x minus -3. So we're going to change that to y plus 5 equals 3 times x plus 3. Now we're going to distribute like we've been practicing. So y plus 5 equals 3x plus 9. That was a plus. And then we're going to subtract 5 to both sides to get y by itself. And we're left with y equals 3x plus 4. So now if we go ahead and graph this line, it should be parallel to our function, our original one, which was 3x plus 2. So now if I type in y equals 3x plus 4, you can see that it is above the line that we previously had. If we looked at the point -3, +5, or -5, we'd be right here, which we did land on. So that's another indicator that we got this question correct. So now let's look at this in perpendicular. So for perpendicular, we said we needed to make our slope the opposite and the reciprocal of our original slope. Okay, so now we're going to make this line perpendicular. So when we make it perpendicular, we have to think about our slope, and we need to do it as our opposite of, if it was positive, it becomes negative, and it's reciprocal. So our slope was 3, and remember that 3 is over 1. So when we do our reciprocal, it's going to be our numerator of 1 and a denominator of 3, and it was positive, so we're changing it to negative. So we're going to get -1 over 3 for our slope. Now that ordered pair is still the same, this one right here. So we're going to have -3, -5 is still the point we want our line to go through. So when we plug it into point slope, we are doing y minus -5 equals our slope of -1/3 times x minus -3. And that would change into y plus 5 equals -1/3 times x plus 3. And now we're going to distribute that -1/3 into our parentheses. So y plus 5 equals -1/3 x. And remember, when we distribute, that 3 is over 1. So 1 times 3 is -3, and 3 times 1 is 3. So we can divide that. So we have y plus 5 equals -1/3 x minus 1. We're going to subtract 5 from both sides, and we get y equals -1/3 x minus 6. Now, when we graph that, we have our original function, which would look just like this. And we wanted to have a slope of -1/3 to be perpendicular. And remember, perpendicular means we're going to meet at a right angle. So, or we're going to intersect at a right angle. So when we put in our new equation, y equals -1/3 x minus 6, you can see this blue line is our new equation. And we wanted it to go through the point -3, -5. So if we do that, it would be right here. So it also goes through our point. There it is, our point right there. And it has our intersection and is perpendicular, making a right angle. Okay, let's look at our next one. So again, it's having write the equation of the line and slope-intercept form that passes through the given point, and part A is parallel to the given line, and part B is perpendicular. So looking at example 2, we have the ordered pair 6, 8, and then we also have this equation for slope-intercept. So if we put that equation into our graph, it's going to look like this right here. And we want to figure out what it would be if it was parallel. So looking at our slope, if it's a parallel line, it should be the same slope. So we're going to leave that as -5/2. And our ordered pair was 6, 8, which they told us right here. And we're going to plug that into point slope. So y minus 8 equals -5/2 times x minus 6. First thing we're going to do is distribute. We have y minus 8 equals -5/2x. Remember, this 6 is over 1, so 5 times 6 is going to be 30 over 2 times 1, which would be 2, and it is a negative times a negative, so we are going to get a positive. And we can simplify this. 30 divided by 2 would get us 15. We're going to look at the subtract 8, and we'll add 8 to both sides. And we will get y equals -5/2x plus 23. So now if I go back to my Desmos calculator and turn this on, I know you probably see it in my first example. You get this for our equation of our line, and we want to make sure this line is parallel, which we can see because they have the same slope, and we are going through the point of 6, 8, which would be somewhere in here. There it is, 6, 8. So we have fulfilled what it needed for that example. Now let's check our perpendicular line. So whenever it's perpendicular, we're going to do the opposite and the reciprocal of our slope. So our slope was originally -5/2, and we're changing it from a negative to a positive, and we're going to make it 2/5 because our numerator is becoming our denominator and our denominator is becoming our numerator. So we have 2/5 as our slope, and we're still going through the point 6, 8, and we're plugging in that into slope-intercept. So why don't you go ahead and pause the video and see if you can solve for slope-intercept. All right, so let's check this. We're doing y minus 8 equals 2/5 times x minus 6. And remember that 6 is over 1. And we're adding 8 to both sides. And if you think of these fractions, if you're stuck, you're doing -12/5, and you are adding, if you make that 8 into an improper fraction, it'd be 40/5. So that would get you 28/5 because you want 8 5s. So you could write your answer as 28/5, or you could say y equals 2/5 x plus 5.6. Okay, so let's check this in our Desmos calculator. When we're looking at this, that red line there was our original line. We want it to be perpendicular, so making a right angle. And we wanted it to go through the point 6, 8. So you can see right here is 6, 8, and it's making that right angle through our original function. So we did good. Okay, we're going to look at the back here. So for this problem, it says write the equation of the line in slope-intercept form that passes through the given point and is A, parallel to the given line, and B, perpendicular to the given line. So this time it gives us a graph of our function, and we want it to pass through the point -4, 3. So looking at our original function, we can see that we have, we can find our slope. We can plot 2 points on this graph. If I pick this point right here, and let's say this one, I am rising 4 and I'm running 2. So my slope is 4/2, or if we simplify, would be just 2. So if we want it parallel, we know our slope has to be the same, but we're going through this time the point -4, 3. It doesn't matter what point you choose for your parallel lines. Whatever point that is, as long as the slope is the same, it's going to end up parallel. In this case, it gives you the point, so we're using that. When we are looking at perpendicular, our slope is going to be the opposite in the reciprocal. So we would do 2/1, and we're changing it from a positive to a negative, and we will flip that reciprocal to get -1/2. And we're still using the point -4, 3. What I'd like for you to do is set up your point slope equation and solve for your slope intercept, and then come back and watch the video. Go ahead and pause. All right, go ahead and check your work. If you have any questions, please make sure you're talking to your teacher. The last thing we're going to do for these is graph the line below. So we're graphing our new function here. When we do this for our parallel line, we can plot this a few ways. We know our equation is y equals 2x plus 11, and we know we have to go through that point of -4, 3. So I actually like to start with that -4, +3, and then I'm doing my slope of rise, which is rise over run, which would be 2, and then it would be over 1. So I'm rising 2, running 1, rising 2, running 1, rising 2, running 1. And then eventually, I know it comes off our graph, we would have our y-intercept be that +11. So although it's off the graph, we can still estimate where it would be, and our function would look like this. And as we can see, those two lines are parallel, so we are in good shape. For perpendicular, we have our original equation here of negative 2x plus 1. So again, I like to start with that point because I need to go through that -4, +3, because that was our original point given to us right here. I know my slope is going to be negative, so my line's going down, and my rise is going to be a -1 over 2, and my run will be 2. So I'm going down 1 over 2, down 1 over 2. And right there, I'm going to notice that my y-intercept is that 1, so I am crossing in the right place. And then I will look at my function here, which we can see is intersecting at a right angle to be perpendicular. If you have any questions, please make sure you are raising your hand to talk to your teacher. Thank you for watching this video.